Alrighty, so for this next problem, you're going to see we're going to have to kind of establish our model, like our equation, and then we are going to use a calculator and plug some things in and see how they work. All right, so let's get our equation first. Let's look at the problem. It says the value of Louise's comic book collection has been increasing by 11% annually. Her collection began with a value of $150. So what they're, and then they said about how long did it take her collection to double. So they're giving us three pieces of information here, right? Even though it only looks like two. They're telling us this, right? So they're telling us rate of growth. So that's going to be our R, and that's 0.11, right? That's how we would write 11%. They're telling us A, right? Our initial amounts. And it says about how long did it take her collection to double. So I think what they're asking there is they're saying how long did it take for this 150 to double? And if you do 150 times 2, right? That's what doubling means, right? You've got 300 bucks. So they're saying they're giving us our final amount too. So they're giving us Y. So they're giving us A is 150. They're giving us R is 0.11, and they're giving us Y, which is 300. So we're going to set up our equation as 300, just plug in our respective parts, 150 times 1 plus 0.11 to the t power, right? And so if I simplify this a little bit, we have 300 equals 150 times 1.11 to the t, right? So what I want to find out is I want to find out what time will it take, right? How many years, right, is it going to take for this $150 to become 300, right? So they're giving us some options here. They say between 5 and 6, between 6 and 7, between 7 and 8, between 8 and 9, and between 9 and 10. Because the only way you can solve this, like with precision, is with using something that we haven't covered yet, which is called logarithms, right? So we're going to instead just kind of estimate sort of where this falls. So the way we're going to do that is we're going to use a calculator, all right? So we're going to put in our equation, right? And so we want, if we go back here, what we want is we want to make sure that this number is basically over 300, but the first value, the first year value that it will take for this to be, for it to double, right? So, so that's what we're looking at, and so we're going to say, so it's going to be 150, right, times, all right, and then it was 1.11, and the first option they gave us was between 5 and 6 years, right? So we're going to raise this to 5, and we're going to see what we get, right? And that gives me 252, right? $252. So, right, 252. So that is too low because we want to be at 300, right? So 150 times 1.11. All right. So now let's try this again, right? And I think, if I remember correctly, you can use the used to be able to use the backspace to redo this, but that's okay. So we'll try it again. We'll go 150 times 1.11, and now we're going to raise it to the 6th power. We're going to see what we get. All right, we get 280. All right, so we're closer, right? So 5 years. At 5 years, it's $252. At 6 years, it's $280. So my guess is going to be it's going to be between 6 and 7. But let's make sure that at 7, it's actually gone over that 300 mark. All right, so we're going to go 150, ignore my cat, times 1.11 x to the 7th power. and bingo, we got 311. So we have cleared it. So we figured that out just kind of by plugging in some numbers, right? And so my answer is going to be letter B, all right? Between 6 and 7 years, because we're at 311 for 7, right? So we got 252, 280, 311, all right? And that's how we're going to do problems like that. We're just going to, we're going to estimate, and it's a little slow and clunky, but that's okay. All right, so that's kind of how these things work. Hope this is making sense to you. There will be another video going over a couple of the homework problems, and we'll see you there.